Good morning, everyone. Welcome to day 2 of the Pittsburgh TechFest presented by Amazon. Before we get started, I wanted to highlight our sponsors for this conference this year. It wouldn't be possible without them. So our main event sponsors, Amazon, and our participating sponsors are IQ Inc., SoftWriters, Aerotech, and General Dynamic Mission Systems. Without further ado, I want to welcome this morning's speaker, Jean Lange.
Hi, everyone. Thank you for being here today. It's lovely to see you all. Speaking of seeing you all, I love human faces and the reactions of them. So if you want to support me as I'm speaking through this talk, it would help me to be able to see your faces. It's not a requirement, but any facial reactions you have will help me out, even if they are of horror or putting some drinks in your face as we go. I want to say a thank you before we get started to the Pittsburgh Technology Council for putting together this conference, which I really enjoyed participating in yesterday. Thank you to all the volunteers there who helped to run it. Thank you to our staff member today, Taylor, who is the program director for the conference. Lucky to have her in our session. Thank you to the folks who sponsored the conference and made it possible for all of us to be here for free. All right. So let me share up my screen here and we'll get started. All right, can you give me a thumbs up if you can see my screen and what's going on there? I love those facial and thumbnail reactions that I'm seeing. Thank you. I want to welcome you to put questions in the chat as we go. If they seem relevant to the moment, Taylor will bring them up to me now. And if not, we'll address them together at the end. But I'm very happy to see your questions and comments and interactions, whether they're now or later. Okay, so first of all, I want to say that the title of this talk is a very good joke. And if you don't understand it now, I'm hoping that you will by the end of the talk. And the way that I acquired this title is by crowdsourcing it on Code and Supply. So thank you to Code and Supply, one of Pittsburgh's local coding communities. Here's how it went. I said, please help me brainstorm this title. And I got a lot of help. So I want to acknowledge Dan Oswalt for coming up with the title that we ended up going with, which I think is really wonderful, and to everyone else for their ideas that helped me as I worked on this. Okay, so my name is Jean Lange. I am a developer and an instructor at Academy Pittsburgh, which is a local coding boot camp. We teach adults software development in 12 weeks, which is an exciting adventure. And these are some of my favorite things. I love Ruby, the language, the most of all computing languages, although other ones certainly have their place in life. I love sticky notes. I want to give credit. The sticky notes in this presentation are snarfed straight from Miro.com, which is my favorite online sticky notes source, which we've used a lot in this last year and a half. I love board games, I love Git. I love lots of things, including your faces. Thank you for showing them to me. But why am I, as a person who loves Ruby, coming here to talk to you about JavaScript today? I'll tell you. The reason is that I know why Ruby is the way that it is. You know, it's got Mina Swan built in. It's directed by this one person. I know how it works. And in our sessions, as we go through the weeks of Academy Pittsburgh, we teach about C# and people learn core programming concepts. We teach them again in Ruby. And then we get about halfway through that 12 weeks and we come to web technologies and we come to JavaScript and people say, why is it this way? What's happening here? What's going on? Why is it causing me this pain? Why is it so different from any other programming language that you've taught me about so far? And I didn't have a good answer to that question. So I wanted to find out, and that's why I'm here giving you this talk today. It is my personal exploration of a story, and here is that story, right? JavaScript is screwy. It's got a screwy ecosystem. It's got all sorts of stuff that are strange and weird about it, but it's used everywhere. And it's used by everyone. So what's going on there? How do we understand those two things? So in order to do that, I took a look through the history of JavaScript to help me understand how it got to be where it is today. and then thought a little bit about how we can make good choices in the world that we find ourselves in today, where it is screwy and it is used by everyone. How can we decide what to do? So that's the story of the talk that we'll be going through today. If you're in the wrong talk, it's fine to hop out and join one of the other sessions. You're only 5 minutes in. All right, so let's talk about JavaScript being screwy. And it seems straightforward, right? JavaScript is a programming language like other programming languages, and that's cool. I know other programming languages and the names of them. And when we get to JavaScript in Academy Pittsburgh, we explain that it's a language for web interactivity, or that's how it was created, right? So where HTML and CSS, which we've just taught about, allow you to make things appear on the page and change how they look, JavaScript is a programming language like the other ones that you've learned that help you to make things happen on the page. Now, there are some fundamental differences about it because it's for the web. And we talk about some of those, like interacting with the DOM or having some events-based things in it. And those are, features of the language that other languages have special features like that too. But then we start running into quirks of JavaScript, things that we have to explain to people, things that are, really potentially strange, things that we had to learn once upon a time and have maybe forgotten about how weird they are about JavaScript. So I'm going to give you a quick refresher on, some of those things that people encounter and say, oh, that's really weird. Why? What's happening? So the first one is the name of JavaScript. It's not related to Java in functionality, which is confusing to every recruiter that, okay, it's not every recruiter. It's confusing to so many people that I have met. And then when you start learning about JavaScript, you also have to learn about Heck-mascript, ES5, ES6, ES 2015. What are these things and how are they related to JavaScript? What are those things? So the name is confusing. There are some fundamental operations in the language that are confusing, and those have been far better expressed than I ever could in a lightning talk called WAT. That's that yellow sticky there, WAT. Taylor's about to put a link in the chat. And if you ever want to go check out the the interesting features of JavaScript in terms of operators, that is a beautiful lightning talk to go watch. My favorite JavaScript part of it is from minute 120 on. It has some good Ruby parts first. So JavaScript has some screwy operational parts that are confusing. Hard to understand why those decisions were made. Let's talk about frameworks for a second. I want you to play a game inside of your head and think to yourself. Now, let's think about another language, one that you know well. Maybe you're familiar with Ruby or C# or Python. Think about a language that you know well and work with that is not JavaScript. Okay, now in your brain, how many web frameworks do you know of for that language? You can show me if you want to. How many have you worked with in that language and created something with? Okay, cool. How many package managers, things to go out and get the libraries for that language, have you used with that language? Okay. Now, if your language is Java, you might have had higher numbers than otherwise, which I was surprised to find out when I went looking up how many frameworks there were for these different languages out there. But for JavaScript, let's think about that for a second. How many frameworks do you know about for JavaScript? In my mind, there's this unscrolling page, right? How many have you personally worked with? My answer is 3. That's more than any other language that I work with. And while languages often have, one standard package management library, JavaScript has at least 2 that you have to know about and understand and work with. So there's this strange proliferation of frameworks in JavaScript world that is sort of different than with other languages. And then finally, we've got some technical details, and I'm going to expand that sticky note a little bit. Let's head over to some technical details. And here are some of the things that come up when you're talking to someone who has not previously worked with JavaScript and has to start, understanding what's going on in it. Some of these come up on technical interviews, and they're sort of trivia questions. I'm not afraid to admit to you that I do not know what the difference is between the 4 types of this that are available in JavaScript and when each one applies. I have to look up examples to make it work. I'm sure there are people out there who know that, and I'm proud of you that you're not me. So that's a screwiness of JavaScript that we encounter. The asynchronous nature of JavaScript, this is often the first time that people encounter asynchronous programming, where you don't, the first line doesn't wait to complete before the next line starts going. And that can become very confusing. Also, JavaScript has many different ways of dealing with the asynchronous nature, which have developed over time, right? You started out with callbacks, and then there were promises, and those are still around. And then there's the whole async await framework. There are probably more. Those are the 3 that I most frequently see and have to read and to explain. But they're, these totally different ways of dealing with the same problem that you have to be able to read and understand them all. Problem, feature. Nothing values. JavaScript has 2 of them, right? And we have to explain to students the difference between null and undefined and what it means to be those 2 different things. Declaring functions. This is a fun one, right? There are about 7 different ways to declare a function in JavaScript. I know about 3 of them that I use regularly, but the website that I looked up how many different ways there are said 7. And they do different things with binding this to the function and several other things. And you have to be able to read them all because you're going to encounter them all in code that you come across. And subtle bugs come up with which one you use. All right. Modes. This was more of a thing once upon a time. Who remembers quirks mode in your browser? Yeah. Okay. So you might set a setting that said, oh, I want you to treat my JavaScript a little bit differently for me, depending on which browser I'm on or how it's going. Transpilation. Transpiling is when you take a language and you run a process on it that translates it into another language of roughly the same complexity. So like JavaScript to Python, for example, would be a transpilation. And it's as opposed to compilation, where you take a language of a certain complexity and compile it down to a more basic sort of language, like assembly code, for example. JavaScript transpiles all the time. And we've got all sorts of libraries and frameworks built into our modern sort of development stack to work with transpilation. For a while, as a young JavaScript developer, I was swimming in this sea of libraries that I had no idea what they did. There was the uglifier, there was the transpiler, there was the webpacker, there was the this and the this and the this and the, all these concepts that I didn't know about. And now I get to explain those to other people. CanIUse.com. This is a useful website that shows you which functions or features of JavaScript and CSS and other web technologies are available in various browsers and versions. So JavaScript is the language where you most have to think about what browsers am I actually going to support. In other languages, you might have to think about what operating system you're going to allow your user to install the final program on. But with JavaScript, it's on, every major web browser that exists. And so users are going to have that on your computer, and you have to say, am I or am I not going to support Firefox version X? And that determines which features you can use as you work with it. So this is a smattering, a selection of some of the things that make JavaScript difficult to explain to developers coming into it, that you may have built up over time and understood, or maybe some of these things are still foreign to you and you're not sure what they are. That's okay. All of us didn't know this at one point also. All right, there's my evidence for JavaScript is screwy. But JavaScript is also everywhere. It has been the #1 most common and popular programming language since 2012. So that's 9 years, according to the Stack Overflow Developer Survey. The GitHub survey says that it's the #1 most common repository language since at least 2014. I didn't see any results further back than that. It's in use by 97.5% of websites. I don't know how they were measuring, but I believe it, that there are that many websites that have JavaScript on it. And it runs not just on the web browser anymore, but on many different platforms. You can write in JavaScript and run something on a server with Node. You can write a desktop application for your computer using JavaScript and other web technologies with Electron. You can write a mobile application that's going to run on your phone with JavaScript using React Native or Ionic. So JavaScript is on every platform. It's used by everyone. It is a hugely common, popular, prolific thing. Screwy everywhere. What's going on? We're going to be on this slide for a while. You can look away from your screen. Here's a timeline, an exploration of some interesting events in the history of JavaScript. How did we get from its invention back in 1995 to where we are today, where it's the #1 language in use? What happened along the way? How did it grow? What were some important events that happened in there? Let's start out with a little bit further back than this timeline with the official invention of the web. The date on that is 1989. So for the first couple of years of the web, what it was, right, was HTML pages, documents, and then URIs that allowed you to move between those documents. And that doesn't sound like so much to us right now, but it was, a new invention, a big thing, super useful. And companies started putting out browsers to navigate the web, and they wanted to differentiate themselves. They wanted to be better than their competitors in some way. And Mosaic was a huge browser. And then some of the people from Mosaic did that common story and left Mosaic and went to found their own company where they could have their own new cool thing, right? And the company they founded was Netscape Navigator. Netscape was a company. Netscape Navigator was the browser that they wanted to create that had all their cool ideas in it that they wanted to be able to make happen. And one of those was the idea of interactivity, of being able to respond to events that happened in the browser. A user clicks and something happens, not just you go to a new page. So they had some ideas for which language they might use, but assigned one of their members, Brendan Eich, to create a language that could be used for this. There's a lot of interesting information about the inspirations for JavaScript and where that came from, but the legend is that in 10 days, he sat down and created the language of JavaScript. This helps to explain some of the things about JavaScript. And it was designed to be perhaps one of many. You know how when you're writing JavaScript, you put that script tag up at the top, and then you can put a Lange attribute on it for which language you want, right? The idea was that you would have many possible languages that would go in that script tag. JavaScript won out, and we'll look at how that happened along the way. But the original idea was, here's one, here's a thing that you could use. And the reason that it was created as it was as a contrast to Java. Where Java was a programmer's language for system engineers and people who had all these chops of doing things with programming. They were going to create Java applets that you could use for interactivity on the web. But JavaScript was a light, happy, fun thing that designers could use. It was intended for people who were not deep into programming, who just wanted to make things happen on the web, to just make cool stuff do without needing to get too deep into what was happening. And so that sort of the design philosophy on it and that marketing of it, first of all, led to a lot of adoption, and was in fact realized in how JavaScript works, so that it became easy enough to use that many people dived in and started using it and creating things with it. And it ballooned in popularity very quickly. And thirdly, that sort of design philosophy of it tainted the image of it for a long time. JavaScript's not a real language, it's a toy language, right? The invention of JavaScript, back there at the beginning in 1995. Well, it did start ballooning. Microsoft made its own version called JScript, gotta avoid that Java name. ActionScript was also sort of another version of JavaScript that existed then. And there was so much going on with it that it became obvious that there needed to be some sort of standardization. So in 1997, this is this next point on the timeline here, ECMAScript. Netscape turned over the language specification process to ECMA, which used to be once upon a time the European Computer Manufacturers Association, but isn't anymore. It doesn't stand for anything anymore because it's not just European. So it's ECMA now. And ECMA is an organization, much like the International Standards Organization or the W3C, that publishes and maintains standards, specifications for things. ECMA is in charge of a whole bunch of interesting things. Other language specifications like C++, C#, and Eiffel. They have published specifications for file systems, the FAT32 file system, CD-ROM, and character sets. So they've got their fingers in all sorts of computer pies there. So they published a specification called ECMAScript that was the pure form that JavaScript was sort of the implementation of. It said, here's what any language that implements ECMAScript has to do. Now, ECMAScript doesn't have everything that JavaScript has. Sort of the classic interpretation of it is that JavaScript is ECMAScript plus DOM plus BOM. DOM is interacting with the HTML on the web page and the styles of it. So that's the ability to the things that are displayed in the browser to see what they are on the page and also to write to them. BOM is the browser object model, and that's the ability to interact with what the browser has done, like the location history of it, like the refresh button, like the back button. So the sort of formula for how JavaScript is different from ECMAScript, at least in the beginning, is ECMAScript plus DOM plus BOM. This ECMAScript standard is also recognized by the ISO, the International Standards Organization, but under a different number. Interestingly, it is not controlled at all by the W3C, which is the World Wide Web Consortium, who are in charge of web standards. It was offered to them first, but they said, we don't want to be in charge of languages, that's too big. So it became a specification outside of the space of the W3C. Interestingly, as we'll find out at the end of this timeline, the W3C was interested in the WebAssembly specification, which is also a big sort of project there. All right. Something interesting about ECMAScript, which is also sort of a historically illuminating fact here, is how often it's been released and how breaking those changes were in specification there. And these green dots along the bottom of the timeline represent releases of ECMAScript. So in 97, you had ES1, first version. 98, you had ES2. 99, you had ES3, and then nothing for 10 years until 2009, so we had 1, 2, 3, and in 2009 we had ES5. What, you may ask, happened to ES4? That 10 years happened. There was a lot of disagreement among major vendors about what should go in there. Some of that stuff ended up in later ECMAScript specifications. But that long gap represents a period of a lot of disagreement and a lot of different implementations of JavaScript by different browsers to add new things into it. And that will play into the next thing that we'll talk about here, which is jQuery and other JavaScript libraries that appeared there. 2009 brought ES5. ES6 appeared there in 2015, and it was also called Heck-mascript 2015. And at that point, they said, oh, these numbers are screwy. So ES6 was the last one that was called ES number, and it was also called Heck-mascript 2015, long awaited. And then there was a release in 2016, 2017, 2018, nothing, and a new one just a couple of months ago in 2021. That first big gap there is especially important, but JavaScript has a well-deserved reputation for changing things up and for making breaking changes with those big releases, especially those two there in 2009 and 2015. All right, so that's ECMAScript and ECMAScript over time there. That's one of those places where all those different function declaration methods comes from. Also, you have to remember that JavaScript is like the web. That's that every web browser, man, I hate the word every major web browser has an implementation of JavaScript, and it has to keep running. You can't break the whole web for everyone. It's a problem when you do. And so JavaScript has kept all these old things inside of itself so as not to break old versions of websites that are out there. And it's added up and added up and added up over time until it's sort of this mass of things all on top of each other, like 7 different ways to declare functions. All right, let's talk about the next point on our timeline here, which is jQuery and in general, JavaScript libraries. We talked about this big time span between ES3 and ES5, where people were using JavaScript and making all sorts of cool things with it and wanting all sorts of new features and things that you could do with it. And so they implemented their own, and every browser had its own version of JavaScript and did things slightly differently, its own engine that would run JavaScript for you. jQuery, which was published in 2006, was the first big mega collection of JavaScript libraries that allowed you to do some of those things that you wanted to do with vanilla JavaScript. Vanilla JavaScript is just the JavaScript specification, no extra libraries on top of it. So jQuery was the first big library that allowed you to add all those extra features that you wanted. Since it was all those extra features, it gained a reputation somewhere between when it was published and now as being huge and bloated and having a lot of stuff you don't need. But in the beginning, it was smaller, and also it had a lot of stuff you did need. For example, a function to do a string find might work one way on Internet Explorer and a different way on Mozilla. And so you use the jQuery library's version of string find instead, because behind the scenes, it checked which browser you were on and did the right thing for you. These kinds of libraries were super necessary if you wanted your web page, your web application to run on more than one platform, more than one browser. jQuery is still used today by 78% of websites. So it's not, defunct, and there have been lots of improvements made to it over time. It's gained a bad reputation, but it's still out there being a workhorse of the web. All right. That 78% of the web statistic comes from w3text.com, and it's an interesting website. If you go look at these slides, there are notes with a lot of links to sources for the information I'm telling you here. This particular site, W3Text, also reports on other JavaScript libraries, because jQuery isn't the only JavaScript library. There are hundreds of them, right? Thousands. It reports on this site reports on the popularity of libraries like graphical libraries, like Bootstrap or HighCharts or D3, right? Those are a common kind of JavaScript library. Functionality libraries like Nodejs, right? And frameworks like React and Vue and Angular. All these things are JavaScript libraries that have become sort of a normal part of our development. Vanilla JavaScript is one way to write JavaScript, but people often use large libraries along with their JavaScript development. So that's a big thing about JavaScript, is these huge libraries that go with it. And that sort of started with jQuery back in 2006. All right, the next point on our timeline here is Node.js. Node.js was first published in 2009. That's where it is on the timeline. And the important thing about this, that's important to our history of JavaScript, is that this is the first time that JavaScript is not just something you can run in the browser. Because originally it was developed as a language for the web, right? But Node.js brings the ability to run JavaScript down to your command line, down to your computer. It provides a runtime environment for JavaScript that is not just in the browser. This lets people write their entire application, both front end and back end, in the same language. If you have all your developers who know JavaScript already, they can write it for the front end, they can write it for the back end. They don't have to learn a new language or context switch. It's seen as sort of a big advantage. It's not a new idea, but it's the first time that JavaScript has the ability to run on the server side there. Node.js is from the OpenJS Foundation, which is a group of people trying to put guidelines and standards around the use of JavaScript. With Node comes, package managers. On the web, when you're just using vanilla JavaScript in a browser, right? The way that you include a JavaScript library is either by putting the code in your folder structure or by doing a link out to where the code is and saying, pull it directly in here, right? With Node.js comes along package managers like NPM and eventually Yarn also. And we start managing our packages a little more, which is necessary. Note that proliferation of libraries down there. So now we have a better way to deal with all these different libraries that are happening, but also another level of things to understand when you're working with JavaScript. It's no longer all just contained within your one HTML page where you're also writing JavaScript. Now we start branching out into that engineering sort of world, right? Where before it was just a toy language just for people to be able to do things on the web, yeah? Now we're sort of edging our way backwards into the engineering territory, which means more layers of abstraction, more things to understand, hopefully also more standardization and fewer bugs. It's the way that JavaScript has gone. All right. With Node also comes Express, which is a web framework for JavaScript. One of the sort of official ones, not the big library. All right, that's Node. Two interesting points that have happened before this on the timeline that I want to point out that are not actually on here are the first specification of CSS. Point with your finger in your brain. Where do you think CSS came in on this timeline? I'll give you a clue, it's already happened. 1996 is the first specification of CSS. So it was not before JavaScript, but it was very early in our timeline here. And then Ajax. Where in the timeline did Ajax happen here? The answer to that is 2005 is where Ajax comes in. If you don't know what those are, that's cool. There are a million things to know about web technologies and JavaScript and how it works. We're talking about some of them here today. All right, so JavaScript has moved to the server side with Node.js in 2009. The next big development I want to talk about is in 2012 when TypeScript was first published. TypeScript, and I didn't put this together until I was thinking about it for this talk, is another implementation of Heck-mascript. Heck-mascript is the standard that says this is what a language has to do to be considered Heck-mascript. JavaScript is one implementation of Heck-mascript with some extra stuff. TypeScript is another implementation of Heck-mascript with some extra stuff. The specific extra stuff that it adds is, again, sort of more programmy stuff, right? It adds the possibility of using types to JavaScript. That's an optional. It was important to the people designing it that it be strictly backwards compatible. And so it's a strict superset of JavaScript. Any JavaScript program is also a TypeScript program, but TypeScript has some more things that are beyond what JavaScript has there. It's from Microsoft. And interestingly, TypeScript was an implementation of the ES 2015 standard, even though it came out in 2012. So Microsoft was sort of ahead of its time there. And the things that were worked out with TypeScript became part of the standard of JavaScript later there. All right, so this is where transpiling starts coming into JavaScript as a language, because the way that TypeScript gets run, right, is not that there's an engine that understands TypeScript and runs that directly, like the Ruby runtime or the JavaScript runtime, right? Instead, there is a transpiler that turns TypeScript into JavaScript, and then the JavaScript gets run by the JavaScript engine. So there's yet another layer of things to understand when you're looking at how JavaScript works. You have to add in that build process of, how does that code get turned into something that the browser can actually understand and run. All right. In 2013, Electron was released. Electron brings JavaScript to the desktop. Just like Node brought JavaScript to the server side, Electron is a framework that allows you to write in JavaScript and HTML and CSS, but instead of being run by a web browser, it's run by your operating system as an app that's on your operating system. And it just looks like a normal app. Some applications that are written in Electron or were at the time that I looked this up on the internet were Visual Studio Code, which just runs and looks like a normal Mac or Windows or whatever operating system you're on application, but is written in these web languages and then uses Electron to compile down into an application. All right, the last point that I wanted to talk about here on this timeline is sort of something that looks like a future of JavaScript. It's still a little newer, and future of JavaScript is a weird way to say it. Let me explain what it is. So in 2019, the first specification for WebAssembly was published. And when we think of web technologies, often they're a little bit singular, right? There's HTML, which is like the one language for markup for displaying a document. There's CSS, which is the one language for styling things. Sure, there are lots of libraries, but they're all CSS, right? And then there's JavaScript, which is the one language for making your web page interact with the user, for being able to click on things, for having events happen. There have been other competitors to JavaScript, especially on the way. I couldn't find any other competitors to CSS. If that's something you know about, I'd love to hear about it. But these web languages have been kind of singular throughout time. WebAssembly is a new standard that is being implemented into browsers of another language for interactivity within the web page. It's called assembly because the code that you write for it, the specification is an assembly type code. It's fairly low level, and it compiles into binary to be able to run in a browser. But the point of it is not to write in WebAssembly, right? You don't want to be writing code on the level of assembly code in order to interact with your user in the browser. The point of it is that you can take any other higher level language and provide a compilation step from that higher level language into the assembly level. And then WebAssembly will then turn that into the binary level, and you can run it in your browser. So just like JavaScript moved from the browser to the server side, now you're coming with any other language that formerly only ran on your server, like C#, like Rust, like your favorite language, whatever it is, and you can use it as the language that you're writing on the web page that runs on the web page, on the user's side of things instead of on the server. So that power of having the same stack across your whole, the same language across your whole application stack that formerly sort of was only possessed by JavaScript, WebAssembly brings that to other languages as well by boosting them up to be able to run in the browser. Now, it's not universally supported yet. You sort of have to turn on a different mode in the browser to be able to use it. But it is growing in popularity since it was first published here in 2019. It also has this cool focus on performance. It's trying to make sure that the interactions with it are running really fast. It is a standard that the W3C cares about and has published. So this standard was published by the World Wide Web Consortium. It has some immaturities currently also. So, you know, this is sort of a new shiny thing, not a standard, but it seems to be growing and interesting and a thing that people are using. Some summary trends that I want you to notice across this whole timeline, right? They're not drawn on here, but they do exist. First of all, that proliferation of libraries and then having to control for that and deal with it in some way. You know, so from those early browser wars, having to make a library that dealt with all the differences between them and enabled you to do cool things, and then building libraries to make JavaScript more engineering-y, to be able to write frameworks there, right? And then needing to deal with that with a package manager, with some way to pack your code down into the smallest space possible so that it could be downloaded by the browser and be run more efficiently, right? That's a trend that has been going across the timeline of JavaScript. I want to talk about single page applications for a second. That was a big buzzword back in the 2010s, and we still talk about single page applications, but it's more sort of maybe like a normal way that things are these days instead of a new exciting trend, right? It's as opposed to that early web idea of having multiple pages, and when you want to go to a different place in your application, you click and it loads up a different HTML page for you, right? And that they're like actually different documents sort of in the background, right? A single page application keeps you on the same URL the whole time. And just you hide and reveal or create different parts of it with JavaScript as you run. And if you're not used to thinking about this, you may not realize that a lot of the things that you use all the time are single page applications. Gmail is a single page application, right? Even though you can do many things within it and look at many different types of screens, it's all always on the same URL, bringing up different parts of it. Facebook is largely a single page application. There's like one section of it that takes you to a different URL. Lots of very functional websites. I just called those functional websites. Lots of very functional websites that we use all the time are single page applications. And JavaScript enabled this to happen, and it's sort of become a normal way that the web operates over time. That's a trend that's changed there. And in order to deal with the complexity of something like an email application or a social media network inside of, you know, a single page on the web, JavaScript had to become more engineering-y. It had to modularize further. It wasn't just all the same code on one little page anymore that a human could look at, that the person who answers the phones can make something happen. Now it's trying to be more and bigger there. And that trend towards becoming more developer-y, into backing into being a real computer language instead of a toy language, is also a trend that's been happening to JavaScript a lot across time. I'm going to take a second to look at the chat here and see if there are any questions or comments that I'm missing here. All right. I hear from my voice in the background that there's nothing I need to respond to at the moment, but lots of interesting commentary for later. Thank you to everyone in the chat there. So here's a timeline of things that have happened to JavaScript. And if we go back and reflect on those questions we had before, right? about JavaScript. Why are you so, why are there all these different ways to do things? Why are there all these different frameworks? Why do you have to understand compilation and transpiling and packing and uglifying and all this other stuff that you have to understand to work in the modern JavaScript world? I think that those sort of trends across that timeline there help to explain those to us. Like, this is why these things are the way they are, is because of the way that JavaScript grew up and developed. I don't know that it makes it a better world to live in, but understanding it makes me feel better about it. So that, you know, that initial marketing of JavaScript, right, as, oh, we're like Java, that very popular development language, but for people who don't have to be super serious programmers. That time compressed development of getting out the first thing in 10 days and then letting anyone play with it and do things with it. That growing with the web and needing to never break. You can't make backwards changes because the web is there, and you can't break web pages for everyone, right? These things have influenced and shaped JavaScript over time and given it a lot of the quirks that it has. They've also, you know, made it into the most popular programming language and used programming language that there is today. All right, we live in this world. This is the world that we're in. Here's where we are. What do we do about it? How do we decide what to use in our projects? How do we decide which JavaScript framework to use? Or if we should use a JavaScript framework at all? How do we make good decisions? And the answer that I have to that is with understanding history, and then sort of the same way that you would make a decision about any other engineering question about which library or framework or language that you should use. First of all, I want to say that using JavaScript is a totally reasonable choice and a totally safe choice. It is used by lots of people for lots of good reasons. So here are some things that I would look at if I were trying to decide, you know, which framework should I use? Which library should I use? The first thing is I would look at ilities. That's that blue sticky down there. And this is, you know, the same as with any other architectural choice I'm making. What's an ility? That's going to be a characteristic of the choice that you're making that's important to you. So maybe performance is really important to you. That's not, it doesn't end with ility. Many of them end with ility, like scalability or securability, no, usability, testability. All those ilities are qualities of the language or the choice you're making. And you have to decide which ones are important to you. When I think about choices about ilities that might lead me to choose one JavaScript library or framework or function or version over another, I might think about, you know, like the popularity and learnability and hireability for that particular framework. You know, does my development team already know React? Well, I'm probably going to use React then. I might think about, so that's sort of a social choice. What is the community like for this thing? Am I going to be able to find good documentation? Am I going to be able to hire people for it? Are they going to be happy working with it because it's something they want to use? I also want to think about some less social choices, like like the longevity of it and the current pace of change that it has. So I might look at, you know, has it been out and have people been using it for a while? This kind of merges into this shiny sticky here. You know, I probably don't want to use the newest thing just because it looks kind of cool and people are all excited about it until it's had time, unless my application is one that can handle new shininess. I'm just writing the game of life on a web page to play with this framework and see how it works. Awesome. Use whatever new shiny thing you want to. I'm trying to create an application that's just for internal use for a small task. Maybe a new shiny thing is fine to try it out, to see how it works. I'm trying to create my company's product that I want people to use online. Probably I want something with a little more support out there and a little that's past its first version that is sort of a standard that people are using there. I also think considering the fit of the library or framework to your application is an important thing to do. And that has to do sort of with understanding the history of it and why it was made and saying, do I have the same problems that the people who had this made? Because you can use any language to do anything, right? So why do you choose one over the other? It's because it's chosen to emphasize certain things, to make certain things easier. And if those are the things that you want to have be easier, well, then it's a good language or framework for you, right? So for example, if we think about web frameworks for JavaScript and the ones that are popular right now, right? React was made by Facebook because they have many different teams that they want to be able to work on the same giant thing. And so they broke up the page into components that could be sort of worked on individually without stomping on each other's toes. If you have that problem, React is probably a good fit for you, right? Angular was created by Google for a sort of giant corporate application, like Gmail. And so if your application looks more like that and less like the Facebook sort, maybe Angular would be a better fit for you. Vue is another slightly less popular framework, was created to be a lighter weight version in reaction to both of those. Easier to learn, easier to get started with, maybe some problems with scalability in the long term there. I don't have any hard and fast rules that say pick this thing over another, pick this version over another. I'm sorry if that's what you came here to hear. I'm here to say you can make engineering decisions about JavaScript in the same way that you can make them about any other language. So that's the story I was here to tell. I hope that you are super psyched about that very good joke back at the beginning about what the Heck-mascript. Thank you again to Dan. If you're interested in these slides, you can find them on my GitHub. Lots of references in the notes there. Thank you again to the PTC, and I'm happy to take any questions now.
Thank you, Jean. Looking through some of the questions, looks like Carissa has one. When you're teaching JavaScript, since it is so expansive and screwy, what do you hope students grasp and walk away with from that unit?
Yeah, so my answer to this is going to be very skewed by the philosophy of Academy Pittsburgh, which is that we're not hoping to teach people everything about JavaScript and make them JavaScript experts. We're hoping them to give people enough of a framework to be able to hook new things on it. So we're trying to sort of break their brain into a little bit of a shape of like, oh, this is how you start doing things with JavaScript, so that they can go out and start learning on their own. I would love it if students exiting Academy knew about JavaScript, how to, experiment with it and to get things to run, and what kind of tutorials cause them frustration versus cause them to learn and move forward, so that they can try to work with the ones that help them to learn and move forward. I see this session rivalry in the chat here. So what I want people learning JavaScript to walk away with is how to keep on learning JavaScript on their own or on the job after they leave Academy.
Trying to scroll through, see if there's any other questions. There's a lot of activity in the chat, more than I've seen in most of the sessions here at TechFest, but I love it. But if you see anything, I
see a good recommendation here. If you're curious about WebAssembly, there was a great talk by Guy Royce about it. That's in those chat notes there, where he demonstrates using it at Erie Day of Code, I think, was where he gave that talk. It's really great. Let's see. Listen, if you have a question that hasn't gotten answered in the chat, bring it back down to the bottom again.
I would agree with that statement.
All right, I see. When do you think Angular proves the most useful? I am being urged to learn it, but everything I see looks rather discouraging. I don't often have strong opinions on which framework or language is the right one. It's more like, what are people using and what fits well with my brain and I like to use. I would encourage you to learn Angular if you've already got something that you're comfortable with and you want to see how a different mind has thought about that. So if you're already comfortable with React, looking at Angular can help you understand what's going on in React by looking at a different viewpoint on the same problem. I think that you should learn Angular if you're going and doing a job that requires Angular, or if you want to interview for jobs that require Angular, absolutely. Why would I choose Angular as the language that I'm writing my personal project in? I probably wouldn't, except for learning purposes, because I'm not making a sort of a big corporate application. I'm probably going to make smaller things. I would definitely use it for learning purposes. I would also go talk to people who use Angular and ask them when Angular is good for them and what's been good about it. Is anyone excited about a non-JavaScript language, Elm, ClojureScript, etc., or Rust/C++ compiled to WASM? Do you think it's worth the overhead of the additional tooling layers and interoperability challenges? I think that this is a great thing to bring to the breakout session that's happening next. Taylor, can you tell people about that?
Yeah, so next up is our networking session. It starts in about 2 minutes. You guys can all go in there and we'll be breaking you up in 3 different 15-minute increments where you can just network with everyone at TechFest, talk through some things. Our staff members will be in the room and to help out with some maybe the awkward conversation of getting people to start talking and turn their cameras on. But it should be a really good time to start have these discussions, I think. For sure. But with that, the comments just keep rolling in at the bottom.
I'm in love with the idea that we provoked discussion amongst the people here. I think that that's a really great result for a talk at TechFest. Yeah. I'd love to hear your take on some of the things that we talked about here in this talk as we move into those breakout sessions.
Yeah. For sure. Well, thank you so much, Jean. It was a great presentation. We are going to leave this room and jump into the networking room. You can find that in your sched. I'll put the link in real quick if anyone needs any assistance getting there. But other than that, thank you so much.
Thank you, everyone. Have a great day.
Thanks, Jean. Bye.